this video on solving quadratic equations by factoring. We're going to begin this video by taking a look at what we've been doing and at some graphs of some quadratics and see how maybe they could relate to each other. So the first thing we're going to want to do is we're going to want to look at this quadratic and we're going to factor it. Okay, so we're looking for what multiplies to 6, and it's a positive 6. That means we're either both positive signs or both negative signs, and adds to a positive 5, which means we're going to have to be both positive signs. We have 1 and 6, and 2 and 3. And so because we have to have both positives, the only thing that's going to add to the positive 5 is positive 2, positive 3. Now, our a value here is 1. And what's nice about the a value of 1 is we can jump straight to the parentheses because there is only one way to split x squared between two parentheses evenly, and that's to have x and x. So we can jump straight into our pair that works is x plus 2 and x plus 3. Okay? The next thing we want to do is we want to take our calculator. So we're going to turn our calculators on. And you're going to want to go into the y equals, and if anything is there, go ahead and clear it out. And we're going to put this into our y equals so we can take a look at the table of values. So it's x squared, so x is right here next to the green alpha button, x, and then square it, plus 5, and then the x button again, plus 6. X squared plus 5x plus 6. And you're going to go to your table, which remember is the second graph button, so we can look at our table. So if x is negative 5, I'm going to look in my calculator. If x is negative 5, y is 6. If x is negative 4, y is 2. If x is negative 3, y is 0. If x is negative 2, y is 0 again. If x is negative 1, y is 2. And if x is 0, y is 6. So what we want to do with these are actually points that we can graph. We're going to graph them on this coordinate plane and take a look at it. So we have negative 1, 2, 3, 4, 5, and then positive 1, 2, 3, 4, 5, 6, negative 4, positive 2, negative 3, 0, negative 2, 0, negative 1, 2, and 0, 6. Okay, so when we graph these, we're going to do more on this later, but when we graph these, we want to give them a little bit of a rounded bottom end. So I'm going to go just a little bit below those two that we graphed on there. Okay. Now, we're going to do the same thing with the next problem and then kind of look at both of these together. So we're going to factor this. This has two terms and there's no GCF. So we got to remember if there's two terms, we want to look for a difference of squares. So this would be x times x. So that's a perfect square. 4 is 2 times 2. So that's a perfect square. And they're subtracting. And so when that happens, we had two parentheses that look the same. So we put 1x in each and a 2 in each. The only difference was one of the parentheses was positive and one of the parentheses is negative. And the reason that works is because when we multiply this back together, this center term, the b value, cancels because the signs are opposite, and that's why we're left with only these two terms. Okay, so we're going to do the same thing that we just did. We're going to put our equation in, so go back into y equals, clear that out. X squared, remember your x is next to the green alpha button, then press the squared button, minus 4. Now let's go look at our table of values. This one starts at negative 3, where my y value there is 5. Negative 2 is 0. Negative 1 is negative 3. 0 is negative 4. 1 is negative 3, 2 is 0, and 3 is 5. So we're going to have a similar sort of graph that it's going to be a U-shaped graph. So we have negative 1, 2, 3 up, 1, 2, 3, 4, 5, negative 2, 0, 0, negative 3, no, sorry, negative 1, negative 3, 0, negative 4, positive 1, negative 3, 2, 0, and 3, 5. And we're going to want to do the same thing. We're going to come down. You don't want to make it a sharp point. You want to make it curve when it comes around. So we have this U-shaped graph. Okay. So what we're wanting to do is we're wanting to look to see if we see any sort of relationship between what we factored, our table of values, and the graph itself. So let's take a look at this first one. I see there's a 2 and a 3, and I got 2 and 3, and they both have, but these guys are negative, but they do both have zeros on them. That's kind of interesting. And then look, because here's your negative 2 and your negative 3 at the x-axis there. Okay, let's look at this one. I have a positive 2 and a negative 2. And when I look here, I got a positive 2 and I got a negative 2, and they both have zeros. So let's go back. Wait a second. Let's look at this again. We have numbers, and the similar numbers have zeros with them. We have numbers, and similar numbers have zeros with them. And then those are the places that the graph is crossing or touching the x-axis. So really what we're seeing is there's some sort of relationship between when we factor and when we graph, where the graph crosses and touches the x-axis. So there's some sort of relationship. That's what we're going to look more into today. Between the factors and the x-intercept. So we're going to investigate that a little bit further and see if we can clarify that. There's just we can just tell there's something going on, but maybe we can't quite grasp it yet. Okay, so let's take a look. Let's go ahead and flip this over and talk about how we're going to go about this. All right, we're going to be doing something called solving quadratic functions. So there's a bunch of different ways to do this. Today we're going to solve them by factoring, since we just completed the factoring section. Solving quadratic functions can tell us where the solutions are, and we've talked about solutions before. Solutions could also be called roots or x-intercepts or zeros. And so if we solve the quadratic function, it will tell us where those x-intercepts are without needing a graph, because you don't always have a graph available to you. We're going to use something called the zero product property. Okay, so the zero product property essentially says, and you guys already really know this already, if you multiply two things and they equal 0, then one of those two things has to be 0 also, because that's how you get a 0 through multiplication, is by multiplying by a 0. How that relates to us is the y value at the x-axis is 0. So for this reason, we want to make the product, meaning the things that we multiplied together, the product of the factors equals 0, so we can determine the x value. Okay, so that's some fancy math talk. Let's really talk about what we're talking about here. So first, let's start with this equation, and we're going to factor it. So a is 1, so I just need to look at what multiplies to -6, but adds to +1. If it's multiplying to a negative, that means my signs are opposite. And we have 1 and 6 and 2 and 3. So for opposite signs to add to a +1, this is going to have to be a +3, and that will be a -2. I can't get to a +1 with this pair, so it can't be that one. This is an a is 1 problem, which means we can jump straight to the parentheses because there's only one way to split the x squared. And then we have a -2 and we have a minus 3. Okay, so what we have here is we have two factors. This is a factor, and then this one is also a factor. What's multiplying together to get to something else? Okay, so we have two factors. So our zero product property says set each factor equal to 0 and then solve it. So one factor is x minus 2. So we're going to say x minus 2 equals 0. And we're going to solve it. This is a pretty easy one to solve. Add 2 to both sides and you get x equals 2. So what that really means is your graph crosses the x-axis at 2. Okay, so without even being able to see a graph, I can tell you with this equation, the graph is going to cross the x-axis at 2. Now remember, those quadratics are U-shaped. They're parabolas. They have 2 arms, so it can cross the x-axis up to 2 times. So let's take a look. Take your other factor, x minus 3 equals 0, and we're going to solve it, and we get x equals 3. So that means the other arm of the parabola crosses or touches, it doesn't have to cross, it crosses the x-axis at x equals 3. So we get in our mind we can kind of envision it's going to go through, the graph goes through, one arm goes through at 2 and the other arm goes through at 3, so that tells you like it's a skinnier section right there. They're pretty close together. So let's kind of take this idea and let's look back at the front again. Okay, so when I'm looking, the x-intercept is always where y is 0. So these guys right here are both my x-intercepts. Okay, now let's take this. We're going to say x plus 2 equals 0. We're going to use our zero product property right there. And when we solve it, it says the graph crosses at negative 2. Well, that's where it's at. X equals negative 2. Okay, so that's this intercept. Then we also have x plus 3 equals 0. And when I solve it, I get x equals 3, negative 3, sorry. And then, so that's where this one is, right there. That's how they relate. And here's his right there. X equals negative 3. So you can see right there it's kind of skinny. It does get wider as it goes up, but right there it's really close together. So let's take a look at this one. Same idea. We're going to take each factor and set it equal to 0. X plus 2 equals 0. So when I solve it, I get x equals negative 2. That's this x-intercept right there. That's where the number comes from. Then I have x minus 2 equals 0. So when I solve it, I get x equals positive 2. And that's this guy right here. So this is, the factors tell us what we would see in the table of values, and it's where the graph crosses or touches the x-axis. All right, let's try some of these and kind of see how we're doing. So before we start, I want to caution you, okay? There's something, this is kind of important because you'll see this pop up every once in a while. To use the zero product property, your quadratic equation must be equal to 0. That means all of your terms have to be on the same side of the equation. So you need to have everything on the same side, so it says equals 0 on the end. Okay, so just be real careful because sometimes those come up. So these first couple, I wanted to help drive home the idea that we're not always going to have the graph to be able to look at. So here we have, let's label these before we start. This says x equals -4, and this says x equals -1. It's a little light. Okay, so when I use the zero product property, I've already factored this for you, so that makes it a little bit easier. So we have x plus 4 equals 0. So when I solve it, I get x equals -4 right there. And then I had x plus 1 equals 0. So when I solve it, I get x equals -1, which was right there. So you can see how they relate directly to their factors. So when we look at number 2, do you see how both of these are exactly the same number? So when I solve it, if I go x minus 6 equals 0, and I solve them, I get x equals 6. Well, I'm going to get the same answer again here because the parentheses were exactly the same. X equals 6. Well, they're the same number. What that means is, take a look at this graph. Here's our x-axis right here. See how the graph is just sitting on the x-axis? Only one point is touching the x-axis, and it's touching it at x equals 6. Okay, so you could so when you see that they have the same number like that, the graph is either sitting on the x-axis, or the other option is it could be hanging upside down from the x-axis. It just means just the one single point is touching it. So let's try that again with number 3. It's just a different way of writing it. Here I wrote them both out. This one says there are 2 x plus 5s. These mean the same thing. And we would solve them. And really, because they're the same, I'm only going to solve this one time, because it's going to give me the same number both times. So when I solve it, I get x equals -5. And when I look at my graph, there it is at -5. Okay. Now one last one. Let's take a look at this graph. Here's your x-axis right here. So this arm goes through at x equals -3, and this arm goes through at x equals 0. So we see that there's 2 zeros there, 2 solutions we can call them. And I see x plus 3 equals 0. So when I solve this, I get x equals -3. Okay, well that's where that one came from. Where did this one come from? Where is it in the equation? If we look right out here in front, that's a GCF that got pulled out. Technically, he's in a parenthesis. He's a factor. So you want to bring him down also and set him equal to 0. Well, he's already done. That's it. It's already solved for you. So that's where this 0 comes in. So you just want to make sure that anything that's pulled out, it's still a factor. So we need to include it in our answers. All right. You will not have more than 2 factors, however, that work, because you can only get the quadratic graph can only go through the x-axis no more than 2 times, because it only has 2 arms. Let's try a couple more. So now we have ones without graphs. Okay, so what you want to do is just factor them, and then once you have them factored, we're going to solve them. So let's take a look. We have a -12. That means our signs of our factors are opposite. So we have 1 and 12, 2 and 6, 3 and 4. Which pair, using opposite signs, can get me to -1? So if I did -4 and +3, that's going to work. So we have x plus 3 and x minus 4. So when I solve them, I'm going to get x equals -3 and x equals +4, because I'm going to add the 4 over to the other side. Okay, so that tells us this is a little bit wider graph at that point, because you can see we're below 0 and then we're above 0, so it'd be a little bit wider out. Let's try let's see, what's another one I'd like you to try? Let's look at number 7. Okay, so there's no GCF. So we want to find factors of 9, and it's a positive 9, which means my signs have to be the same. That's going to add to negative 6. Because we're trying to go to negative 6, my same signs are going to both be negative. So the factors of 9 are 1 times 9 and 3 times 3. So if I make both of my 3's negative, which we said it had to be, that would work. That's negative 6 in the middle, and negative 3 times negative 3 is positive 9 on the end. A is 1, so we can shortcut here, because the only way to get x squared is to split those two x's, 1 in each. And then we have minus 3 and minus 3. Notice they're exactly the same. So when I go to solve them, I'm going to get the same answer twice. So that means this graph is only touching the x-axis 1 time. So it's sitting on it. And I know it's sitting on it because this is a positive. We'll get more into that as we keep moving forward. So this is sitting on the x-axis where x is 3. All right. Another problem that I really want to try with you is I want to look at 9 and 10 here. Remember, I said there is a caution. If we look back over here, here's your caution. Make sure it has to say equals 0. Okay, it has to say equals 0. When I'm looking here, these guys do not say equals 0. So I'm going to start with number 10 first. So this says equals 15. What I want to do is I want to move the 15 back over to the left-hand side. Okay, so to cancel it out, I'm going to subtract 15 from both sides. And we end up with 2x squared. We want to keep this in standard form, so the next one would be minus x, and then minus 15, and then we're going to write equals 0, because 15 minus 15 is 0. So now we want to factor it. Notice that the a is not 1, so we have to remember to multiply a times c. So 2 times negative 15 is negative 30. And a negative number means my signs are going to be opposite from each other. It's really important to understand how your signs are working. So we have 1 times 30, 2 times 15, 3 times 10, and 5 times 6 all make 30. They have opposite signs, and we're trying to get to negative 1. Well, the only ones who are 1 apart are this 5 and 6. And since it's a negative 1, I'm going to make the 6 negative and the 5 positive. Now, this is the longer method. We're going to use something called grouping because we don't exactly know how our numbers are going to pair up with this 2. So we're going to have 2x squared. I'm going to substitute these guys in. Instead of negative 1x, I'm going to change how it looks. I'm going to start with the negative 6 because I think it pairs better with 2, and then plus 5x. Because I feel like that pairs better with the 15. It doesn't matter. You could have done the other order and it will not make a difference. So this gives us 4 terms. Remember, negative 6x plus 5x is negative 1x. So I have not changed the value, just how it looks. I'm going to split this down the middle. And remember when we did this before where we only look at 1/2 at a time? We have these 2 terms that have a 2x in common. So our GCF is 2x, and we're left with x minus 3 after we remove our GCF. And now let's go GCF the other side. There's a positive sign there, so make sure you bring down your positive sign. 5x and 15 have a 5 in common. It's a positive 5. And you're left with x minus 3 once you pull that 5 out. So when we remove this, we have the same parentheses. We have 2 terms here, term 1, term 2. They have a GCF of x minus 3, so we want to factor out the x minus 3. They cancel, and what's left behind is 2x plus 5, and that is what goes in the other parenthesis. So that's factored, but remember, we're solving. So you want to take the one more step. X minus 3 equals 0. add the 3 to both sides, and you get x equals 3. This one's a little bit, it's not trickier, it just takes a couple, it has one more step to it. It's a 2-step solve. So we say minus 5, for following our proper solving method. 2x equals negative 5. Divide both sides by 2, and we're going to get x equals negative 5 over 2. So that means that number is really negative 2.5. That goes through the x-axis at negative 2.5, and this other arm goes through the x-axis at positive 3. Okay, hopefully this was helpful. Try the assignment where you're matching the graph to the equations. You put your answers in Canvas, and I will see you in class.